Okay, notes 5.2 part 3. For each of the following elements, write their short form electron configuration and number of valence electron. Then do the same for the ion that each is expected to form. In barium's case, it's down all the way here. That's S. 1, 2, 3, 4, 5, and 6. So 6s2. The short form, if we go back, we have xenon. Xenon 6s2. Alright, in the case of barium, check it out. It's one of those group 2 metals. Look, you see that? Group 1, group 2, right there. That means it's got 2 valence electrons it will give away freely. It'll just give them away, just like magnesium. Remember that example that I showed you with magnesium? It's in the same group as magnesium. There's magnesium, there's barium. So we give away those 2 electrons. So the number of valence electrons is 2. The expected ion, if it gives those 2 away, is 2 plus, or plus 2, but we say 2 plus, which is better. Oops, Ba2 plus. Okay, Ba2 plus. What will it look like if it gives away those 2 electrons? Well, it's only got 2 to give away right here. Okay, so what happens is those go away. It just becomes, its configuration then becomes xenon. And how many valence electrons does it have? 0. It has no more. Well, that's actually not true. It doesn't have 0, but we can say 0 for right now. Okay, that's not true. It's got more than that. But I'm not going to get into that. That goes beyond the scope of the class. Okay, next up. Tellurium. Tellurium, where did you go? Oh boy, I lost it. It's over here somewhere. Okay, I got distracted. A visitor. Tellurium is what we're doing next. Tellurium starts at krypton, and then that's 5s2, 4d10, and 5p1, 2, 3, 4, if I'm not mistaken. Okay, so here we go. Krypton. Oops. Krypton 5s2, 4d10, and 5p4. Alright. How many valence electrons does it have? Well, it's in oxygen's group. Oxygen has 6. Okay. 1, 2, 3, 4, 5, 6. Okay. Tellurium also has 6. Okay, if it's got 6, it's not going to give those whole 6 away because that takes too much energy to do that. Instead, it's going to attract 2 additional. So its expected ion is going to be Te2 minus. Te2 minus. Okay, if it gains 2 additional electrons now, what's its configuration going to look like? Well, it's going to still have the same configuration, but check it out. We're going to gain 2 electrons over here, right? We're going to gain 2. We'll say 1 and 2. But we don't just say xenon. That's incorrect to do that. We say krypton, 5s2, 4d10, and 5p6. Oh shoot. 5, that's a 5. 5p6. And the number of valence electrons, 8. 8. Okay. Here's why we don't just say krypton. After all, if we were going to do argon's electron configuration, argon's electron configuration would actually be neon 3s2, 3p6. We can't just say argon. Okay, we have to specify. Okay. However, if we said calcium, we could start at argon and go argon 5s2 or something like that. Is it 5s2? 4s2. Okay, but if you're each noble gas has its own configuration. You can't just call it a noble gas and have that be the end of it. You got to specify its configuration. Okay, but you can also write a noble gas in short form configuration as well, and that's what it would look like. What about cadmium? CD. Cadmium, CD. And that cadmium, if I'm not mistaken, is... Boy, where is it? I'll be right back. Okay, there it is, cadmium. Cadmium, transition metal. Go back all the way to krypton. Let's start here. Krypton. 5s2, 4d10 is cadmium. So krypton, 5s2, 4d10. Alright. How many valence electrons? Okay, this is where we're starting to get into these weird... I'll just tell you, okay, the S, you look at the highest number here to figure this out, and it's 5s2. And I'm not going to get into why that is. Honestly, this example shouldn't be in these notes, in my opinion. Okay, it's got 2. And this is the same thing that happened back here with this iron 2. Remember that? These guys have to go away. Alright. So if it's got 2, its expected ion is going to be CD2+. And we lose these S. We lose these S electrons. So our configuration is going to look like this. Krypton, 4d10. Don't ask why that is right now, okay? Just don't. That concludes that video, and perhaps I'll do one more on Lewis dot structures.